MAT 3531 Differential Equations 2 Lesson 4 Part 1 Second Order Partial Differential Equations. In this chapter we discussed about the second order partial differential equations with variable coefficients. So then first of all we have to know about these notations. If you have present R in this chapter, so it means second order partial differential equations. R means dabba square z over dabba x square. S means dabba squared z over dabba x times dabba y, and T means dabba squared z over dabba y square. So you have to remember these notations. So if that x R is given in the problem, you can use dabba squared z over dabba x square, as well as S and T is given. You have to use these two forms to solve these partial differential equations. Right. And there are some more notations. So PQRST is there. So P, I explained, P is da by z over da by x, Q equals da by z over da by y, and R equals da bar squared z over da by x square. It means this one you can write da bar over da by x times da by z over da by x, this one. And so da by z over da by x is P. It means instead of this R is equals to da bar P over da by x, right? This one also you can take from this equation. And T is equals da bar squared z over da bar y square. This is you can write da bar over da bar y times da by z over da bar y, but da by z over da bar y is equals to Q. Then T is also equals to the da bar Q over da bar y, and S equals da bar squared z over da bar x da bar y. It means da bar over da bar x times da by z over da bar y. Da by z over da bar y means Q, right? Da by z over da bar y means Q. It means you can write da bar Q over da bar x, as well as you can write this in this form also, da bar over da bar y times da by z over da bar x. Da by z over da bar x means P. It means that is also equals to da bar P over da bar y. So you have to remember those notations, because when we are solving the problems you need those notations. If we don't have this knowledge of this notation, it is difficult to solve these problems. So remember those, what is P, what is Q, what is R, what is T, and what is S, and also how to do the conversion of these PQRST for the for convenient for the given problem, right? Then there are three types to find the solutions for the given second order partial differential equations. Type 1 is so if R is, I explained earlier, R is this one, T is this one, and S is this one. So we will consider this type 1 through an example. Yeah, this is example 1. Solve R equals 6x. So I told you have to remember what is R. R is da bar squared z over da bar x square, that is equals to 6x. So you need to find S. For that, so first you can integrate with respect to x, right? So you have to integrate this. It means da bar squared z, you have to integrate, then 6 times x da bar x, right? Then if you simplify this, integrate this, here remain in da by z, and 6 x square over 2 plus you have to add the constant. Constant is I am adding 5 1, this is a function of y, right? That is written in there, right? So you differentiate, you integrate one time, but 5 1 is a arbitrary function of y. Okay, so then you can find da bar z over da bar x equals 3x square. You can divide this one, 3x square plus 5 1 time 5 1 of y, where phi1 of y is an arbitrary function of y. So you have to define what is it. If you are adding the constant, you have to define what is it, right? Then that is not the final answer. Now there you found that da by z over da by x. Now you have to integrate this again with respect to x, then equals 3x square times da by x plus phi 1 y times da by x, right? So if you integrate this, here remaining a z, and this one 3, sorry, this one you have write 3 x square da by x, it means 3 times x to the power 3 of, then phi 1 y times, if you uh, integrate da by x, that is come as x plus another constant, that is I am adding as phi 2 y. So then we have to define phi 2 y is an arbitrary constant of y. Then you can simplify this, and finally you can write z equals x cube plus x times phi 1 y plus phi 2 y, where phi 1 and phi 2 are the arbitrary functions of y. This is the answer, right? Another example, then ar equals xy. So you know that r, according to the definition, r equals da bar square dz over da by x square, right? Then I can send this a is a constant, so that coefficient I am sending for the other side. Then da by z, da bar square dz over da by x square is equals 1 over a times xy. So then integrating with respect to x, we can integrate both sides. Then we can get here da by z over da by x, and 1 over a is a constant. Then y is also a constant, because we are uh, integrating with respect to the x. So then we have to integrate x. If we integrate x, that is x square over 2 plus at constant is phi 1 y. That is a arbitrary function of y, right? Again, now you can take this as da by z over da by x equals 1 over a y. 1 over a times y is x squared over 2 plus phi 1 y. Then to find s x, to find z, you have to integrate this again with respect to x. So then you can write here you have to integrate, and here also you have to integrate. This can be right in here da by x, here da by x, right? If you integrate this, here remaining z, right? Then 1 over a y remaining there, then x cube over 3, x cube over 3 plus x times, then phi 1 y times x plus another constant. So this can you can simplify. Then finally you can take phi y cube y x cube over 6a plus x phi 1 y plus another constant, where these constants are arbitrary functions of y. This is the way of solving these types of problems. There is another example, then, that is t equals x times y. You know that according to the definition, t is equals d squared z over dy squared equal x times y. So then this one you can first you can integrate this with respect to y. Now dy da by y squared, then you have to integrate with respect to y. Then here if you integrate one times, that is come here that in this part da by z over da by y, and x is a constant. Then if you integrate with respect to y, that's come y squared over 2 plus a constant, that constant is arbitrary function of x. Okay, so then you can simplify further this. Then da by z over da by y equals xy square over 2 plus phi 1 y. To find z, you have to integrate this again with respect to y, right? Then here da by y, and also da by y is there. So you have to integrate this again. Then this part come as z, and x over 2, then y cube over 3 plus here creating y. So if you integrate da by y, here answer is y times y1 x plus another constant, where this constant is an arbitrary function of x. So finally you can write xy cube over 6 plus y time function of x plus another constant, that is function of x. So this is the answer. So right. Another example, solve x y x equals 1. So then here the uh, s is there, so we have to subject x first, then s equals 1 over xy. Then you know that according to the definition, s you can write da bar squared z times da over da bar x times da bar y. This you can write da bar over da bar x times da bar z over da bar y, right? So first you can it means now here this equation you have da bar x times da bar z over da bar y equals 1 over xy. So you can integrate this da bar times da by z over da by y equals 1 over y times 1 over x da by x. So you are going to integrate with respect to x, then what is can this cancel, then da by z over da by y is creating there 1 over y, 1 over x means ln x plus a constant that is a function of y, because if you are that is phi 1 y, okay, right, because you integrate with respect to x, then it's come as function of y, that is constant. Now uh, now you can simplify this, you can integrate this again with respect to y, then so what happened, then we'll see da by z is there equals ln x 1 over y da by y plus phi 1 y times da by y. If you integrate this here, creating z equals ln x times 1 over y means ln y plus, here I can add another constant, that is function of y, plus another one, because this constant is this one, then if we take phi this new one y is equals this one integration of phi 1 y times da by y plus another constant 2y. So these two constants are functions of y, right? So you can write the final answer as z equals ln x times ln y times these two constants, because where this constant is equals to integration of phi 1 y dy, and also these are being arbitrary functions. Okay, so these are the simple calculations when solving the second order partial differential equations. So example 5, xr equals p. Then you know that what is r equals da by square z over da by x square, and p is equals da by z over da by x. So I am a subject in this one, then da by square z over da by x square equals 1 over x times da by z over da by x, right? Then I can send this for that side, then it is creating da bar square dz over da by x square divide by da by z over da by x equals 1 over x, right? So then I am going to integrate this, right, that is with respect to x da by x. Then what happened? So this is and differentiation of this in the numerator. Here denominator is there, then differentiation of the denominator is in the numerator. It means that you can write ln this one, because here the term is there, then differentiation of term is in the numerator, then you can write that is ln da by z over da by x equals, this is also ln, no, that is also log o ln, you can write ln x plus another constant, that is also I can write ln phi 1 y, right, this one, right? After that you can this is addition of logarithms, you can write as a what multiplication, then phi 1 y, then you can take the antilog of both sides, then da by z over da by x you can take as x times phi 1 y, this one, right? Then you can take this part. After that, so if after taking this one, right? So I am getting for the other page, right? So then this one we can integrate with respect to x. Then here in this side creating z, and x times da by x means 5 and y times this x. If you integrate x squared over 2 plus another constant, another function that is a constant 5 to y, then finally you can write the answer as z equals x square over 2 times a constant plus another constant, where these two constant that is a function of y, right? That is the answer. Then example 6, solve xr plus 2p equals 0, right? So then we can rewrite this equation by substituting what is r equals da bar squared z over da by x square, right? So this can be right da bar over da by x times da by z uh, over da by x, right? Da by z over da by x plus 2p, right? Da by z over da by x means what is it? P, right? This is equals to p, right? Instead of this we can write p. Then x times da by p over uh, uh, x times da by p over da by x plus 2p equals 0, right? So if there is a x in there, so you know that linear equation, so y dash equals sorry, y dash plus p of x y equals q of x, right? So we can create this for that form. To do this you have to multiply. So here x we need, no? So x, then this here x, no? So if it is y there, we have to write y. Then if you need, I am writing x dash equals p of p here, p, no? P of p equals q of p, right? So then x dash is there, right? Sorry, not p dash is there, p dash x, q dash x, right? P dash is there. So then here we need x, right? Here we need x. For that we have to multiply the whole equation by x. Then here creating x square plus da bar x da bar p over da bar x 2xp, here 0. Then now this is a linear equation of the form this one. Then here p of x equals p of x equals, oh the just you can write it there, no? So if you need, you can write using the linear equations, but if you see this one, you can see that what is this, that is a differentiation of x squared p. So if you differentiate x squared p, what we get if you differentiate this one, x square times da by p over da by x plus p times, if you differentiate this, that's come t 2x, no? Right? Then if you look at this one here, x square times da by p over da by x plus 2xp, no? It means that is this one. You can write this one in this form. Then you can integrate this, right, both sides. Then what happen here, this is creating a constant and here remaining x squared p, right? So here you can write x squared p times a constant, right? Then you knew that what is p? P is equals da by z over da by x. Then again you can integrate this one. Then if I send this for that side, that is 1 over x squared. Then integrating with respect to x. So if we integrate this kind, z is creating there. Then what is it? 1 over x square. If we integrate 1 over x square, what happen? X square is goes to up x minus 2. Then if you integrate this one, what happen? x minus 2 plus 1 over minus 2, no? Then what happened here? X minus 1, then minus 2 plus 1 means minus 2 plus 1 here, then that is minus 1. Then here creating z equals minus 1 1 over x times a constant plus another constant, where those two constants are being the arbitrary functions of y, right? That is a way of solving type 1 equations. Now we will consider about the type 2 partial differential equations. It means if we can convert these equations for that form, and we can solve those partial linear ordinary differential equations. Like this is the example: t minus x cube equals x square. If that given is that form, you know that t, what is t? Dabba q over dabba y minus x, right? So you know that t is equals dabba square dz over dabba y square, no? That is t equals this one. Then you can write t as dabba over dabba y times dabba z over dabba y. But you know that dabba z over dabba y is equals q, no? Then you can write dabba q over dabba y. That's why here t equals dabba q over dabba y, right? Then minus x cube equals x square. So now what you can see, this is a linear equation of the form. What is a linear equation? Form of the linear equation: p dash plus p of x q equals q of x, where p of x here, p of x is equals to minus x, right? P of x is minus x, and q of p of y, no? P of y, here's p of y, q of y is equals to x square. Then you can find the integrating factor for this one. Integrating factor I of x, you can find e to the power square root p of x times dabba x, right? You found p of x means minus x, so e times minus dabba y, no? Minus x times dabba y. X is a constant here, then you can write e times minus xy. That is the integrating factor, right? Integrating factor you found as e times x minus xy. So then after finding the integrating factor, what you have to do, you have to multiply this whole equation by integrating factor. So it means you have to write here minus e times minus xy, here e times minus xy, and also here e times minus xy. So after writing this, you can take this equation. So e to the power minus xy times dabba q over dabba y minus x times e to the power minus xy times q equals x squared times e to the power minus xy. So now that this thing you can write e to the power minus xy over q, right? This this side you have to write as it is. After that you can integrate with respect to y, then here remaining this, cancel this part, then here remaining e to the power minus xy times q equals integration of x square e to the power minus xy times dy plus a constant, right? So you can simplify this further with respect to y. Then if we consider with respect to y, x squared is a constant, then e to the power minus xy integration of this one, e to the power minus xy divided by minus x, right? So then you can take e to the power minus xy times q equals minus x e to the power minus xy times q a constant phi 1x, right? So now you know that q, instead of q we can write q is equals dabba z over dabba y, right? So by substituting da by z over da by y for this q, we can simplify this equation further, right? So then here e to the power minus xy, then instead of q we can write da by z over da by y equals minus x times e to the power xy plus phi 1x, right? So then we can integrate this again. Before that we can divide whole equation by e to the power minus xy. If we divide this whole equation by e to the power minus xy, what happen? Here e to the power minus xy is cancelled, then this one is goes to as e to the power minus xy here remaining. If you take this for the numerator, what happen? This minus sign cancel and it is come as positive. Then we can integrate with respect to y again. So if you integrate this one, what happen? So I can integrate this one da by y and this one da by y. So here z is creating, then here da by y means y is creating this minus xy, and if you this you have to integrate, and you have to add then a constant. So if you integrate this one, what happen? E to the power xy divided by x, right? So here thing is doing done. It means phi 1 over x, this one taken as another constant. He introduced another constant as this one, and this constant is there. So finally you can write the answer. If you keep the answer as this way, that is also correct, but here we can introduce another constant, and finally you can take the answer as z equals minus xy plus two constants times e to the power xy, right? And then second example, solve xs times plus q equals 4x plus 2y plus 2. Then we can rewrite this one. You know that s equals da by q over da by x, right? So then this is a again this is a linear equation, so you can take you can see that is this part you can write da by over da by x times x cube. So this part we can write as it is, and then you can integrate with respect to x this part. Then what happen? This one integrate, and this da by x and da by x. So what is creating the x cube is there equals 4 times x square over 2 plus 2y times x plus 2x. So 2x, 2y times x, 2x plus constant. So you can simplify further. X cube equals, then here we can plus 2, then 2x square plus 2xy plus 2y, then a constant. Then I am dividing this whole equation by x. Then what happen? Here remaining only q, and 1x is cancelled there. Then here 2y remaining, then this x is cancelled, then 2. Then finally here creating phi 1y over x. Then now you know that q is equals da by z over da by y, right? Da by z over da by y. Then we can integrate this whole equation with respect to y. Then what happen? Here is z remaining, then here da by y is coming, this da by y is goes to there, and again da by y is goes to there, da by y is goes to there, and da by y is goes to there. Then what happen? Here 2xy, then 2y squared over 2 plus 2 here y plus 1 over x times this integration of this we can introduce as another function, this function for here, and also another constant, right? So then what is the final answer? Then 2xy times, here you can cancel, then y square plus 2y 1 over x, then this function we can introduce, and another constant, this one. Then what happened? These are two arbitrary functions, right? This is the last type, that is a type 3. Under these types we consider the equation in these forms, right? So we will consider an example, right? First example, t plus s plus q is equals to 0. Then you know that according to the definition, t equals da by q over da by y, S equals double p over double y, and also q equals double z over double y equals to 0. Then so we can integrate this with respect to y. Then what happen? Q plus p plus z is equals to function f of x, where this is an arbitrary function, right? So then now we can rearrange this equation: p plus q minus f of x, x minus z. uh, so then what you can see, this is a linear equation uh, of the form, what is the form? Y dash plus p of x y plus q of x equals q of x. Then here what is p of x? P of x equals 1. Then uh, q of x equals f of x minus z, no, this one. Oh no, that is not so we can consider this form, no, sorry, that is not linear form, we have to consider this form, right? So then what is p? Capital P is equals 1. Then capital Q here also 1. Then capital R equals fx minus z. We have to consider this equation, right? Then you can write, if it is given in this equation, this form, we talk about how we can simplify these equations in the previous lessons. So we can write dab x over p, dx over p equals dx dy over q equals dz over r. Dx over p equals 1, no, then q equals 1, then dz over f of x minus z. Then first we can consider dx equals dy, then we can integrate both sides. Then what happen? X equals y, then x equals so if we integrate this, we can write x equals y plus c1. Then if you take this time, x minus y equals c1, where c is being an arbitrary constant. Now we can consider this one, dx equals dz dz f z minus y. So we can take we can write da by z over da by x equals f of x minus z. So we can take z for that side. Then it is creating da by z over da by x plus da z plus f of x. So what is this? This is a linear equation. Now what is the form? Z dash plus p of zy equals q of z. So here p of z equals what is it? 1. P of z is equals 1, and q of z equals f of x. So then we can find the integrating factor for this one, I of x, that is e to the power integration p of x times dx e to the power. So p of x means p said here 1 times dx, it means integration factor is equals to ex. So what you have to do here, integrating factor you found as ex, then you have to multiply whole equation by e of x. So then what happen? E to the power x dz over dx equals e to the power x times z equals f of x times ex. Then you can write this as d over dx times ex times z, then f of x times ex. Now you can integrate with respect to x, then here creating e of x over z, then f of x ex times dx. So you can introduce function for this one, that is 5x, then plus s2. Then finally you can write c2 equals z times ex minus 5 of x equals c2. Then the general solution you can write as this way, as we discussed in the previous lessons, equals to the 0. So these are the three types of solving the given partial differential equations, right? So then I think now you can simplify any partial differential equations in the second order to solve these things. So definitely you have to remember what is p, what is q, what is r, and what is s, and what is t, and also the different form of this one, how to write r as a function of p, that's the derivative of p, and also t, how you can write as a derivative of q, and also s, how you can write as a derivative of q, and also and the derivative of p. So if you know how to substitute to these these PQRS and converting into the known differential equations, then you can use the previous methods we discussed in the previous lessons to solve these second order partial differential equations. Now I think you have a clear understanding about how to solve the second order partial differential equations, and for this lesson also you have a tutorial. So do it and submit within the allocated time. If you have further problems related to this lesson, you may contact me. Thank you very much.